Hello, welcome to lesson 8 in our intro/algebra review. This is our last lesson of the algebra review that we'll be doing. So today what we're going to do is our final way of solving quadratics. We're going to do this using the quadratic formula. So the quadratic formula works for any quadratic that you can think of, because not every quadratic can be factored and not every quadratic can you use square roots for the way that it's written. In the future, you will learn ways to rewrite quadratics. That's the fourth way of solving quadratics, and that's called completing the square. But for now, we are not going to cover that method. So when you have a quadratic in standard form where you have a is in front of your x squared, or your x squared term, your quadratic term, b is in front of x, and c is your constant, the quadratic formula will work. X is going to equal the following. It's the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. There is a song that teachers sing. It goes to the tune of Pop Goes the Weasel, where it would be x equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. And I know there's other versions on YouTube as well that maybe your teachers last year have shown you. I know some of my students have told me that they've learned different versions of this song, but any way that you can, any method that you can use to remember this formula, which is pretty scary looking when you look at it, would be great. So the first thing to do when you are solving using the quadratic formula is to set the equation equal to 0. It has to equal 0. So when you start off a quadratic, when you are going to be factoring or using the quadratic formula, that first step is exactly the same. You want to set your equation equal to 0. All right, so let's take a look at number 1 over here. Let's read the directions together first. It says solve each equation using the quadratic formula. Give simplified, exact, and approximate solutions. Round your approximate answers to the nearest hundredth. Therefore, we will need a calculator. So if you do not have one in front of you, please pause the video, go get a calculator, because typing this in sometimes when we have to give both solutions is a little bit challenging for some students. So go ahead and get a calculator if you don't have one already. When we assess quadratic formula, you are going to have to, it's going to say give the exact and approximate solutions. Okay, so let's look at number 1. 2x squared plus 7x minus 9 equals 0. My first step is done for me. This equation does equal 0. So I look at my quadratic. I like to go ahead and write down what a, b, and c are in this quadratic equation. A is the number in front of x squared. It's the coefficient of the squared term. It's 2. B is your linear coefficient, so 7. C is negative 9. Okay, so when I do quadratic formula, I sing the song to myself. If you have a different version of the song that you sing, that's great. But either way, if it helps you remember this formula, then go for it. So x equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. Notice that I say the opposite of b. I don't say negative b, because a lot of times students will think if it's negative that means you don't have to change the sign. You always change the sign of b. So now what I do is I'm going to clean up the numbers underneath the radical sign. I'm first going to square whatever b is. I square it. Whether b is positive or b is negative, that first number underneath your radical sign should be positive, because keep in mind that if I have something like this versus this, these are two very different things. The problem is we say both of them the same. I think most people would say this first thing as negative 4 squared, and the second thing they would say as negative 4 squared. So technically though, the first one you should say the opposite of, this is the opposite of 4 is being squared. So if you were to write that out, it's this, which would equal negative 16. It's the opposite of 4 times 4. Whereas the second one, negative 4 is being squared. So you would say negative 4 squared. Negative 4 times negative 4 is positive 16. So you have to be very careful. When you square the b term, it's always in parentheses, so you should always get a positive number. Second thing I want to draw your attention to, another mistake kids make, I like to look at the minus signs and see how many I have, because many times kids do mess that up. They think it's negative when it should be positive, or positive when it should be negative. I see 2 minus signs, so I know my second number is going to be a plus. Plus what? Well, 4 times 2 is 8. 8 times 9 is 72. And then this is all going to be over 4. Okay, so moving along, I kind of took up a little too much space here. I will have x equals -7 plus or minus the square root of 49 plus 72 is 121 divided by 4. At this step, you want to simplify your radical if that's possible. I noticed, hopefully you noticed as well, that the square root of 121, that's going to be a nice integer because 121 is a perfect square. So this is going to equal -7 plus 11 over 4, and then -7 minus 11 over 4. Don't forget that this plus or minus is an abbreviated way to write both of those expressions. It's -7 plus the square root of 121 all over 4, -7 minus the square root of 121 all over 4. So because 121 is a perfect square, I do rewrite both of them individually. -7 plus 11 is 4 over 4. -7 minus 11 is -18 over 4. So x is going to equal, let's reduce these, 1 and -9 halves. If I was to take these two values of x and plug it into my original equation, they're both going to end up equaling 0 on the left equals 0, and I could check my work that way. I know I said you have to have exact and approximate solutions. Because these worked out nicely, this is exact. I don't have to worry about approximate. If I had something like square root of 2 is my final answer, then I would have to use my calculator and approximate it. Okay, let's take a look at number 2. The only difference to start off here is that it's not equal to 0, so I will make this equation equal to 0 by adding 1 to both sides. I end up with 3x squared minus 5x plus 1 equals 0. Once it's in standard form, I like to label what A, B, and C are. A is 3, B is -5, C is 0. Standard form meaning I'm writing it in decreasing order of the exponents. So let's go ahead and type or plug into the quadratic formula. X equals the opposite of B, becoming a +5 plus or minus the square root of -5 squared minus 4 times A times C all over 2A. Let's clean up underneath the radical sign. 5 plus or minus the square root of -5 times -5 is +25. That first number should always be positive. I go and count my negative signs. There's only one. So it's going to be minus 4 times 3 times 1 is 12 over 6. This is going to equal 5 plus or minus the square root of 13 over 6. At this point, you look at the radical, square root of 13. Can that be simplified? No, it cannot. So this is my exact answer. My approximate answer, I have to plug into my calculator. I am going to get, just like we practiced with lesson 6, we practiced typing this in. In your calculator, type in 5 plus the square root of 13. Press enter if you have a graphing calculator. Divide by 6. Then do the same thing but with the minus sign. Here are the two approximate solutions you should get. X is approximately 1.43 or 0.23. And that is all that we could do for that problem. That's it, we're done. Okay, let's look at number 3. We'll do this one together, and then I will leave you to do number 4 on your own before we do the back page, which is using the best method. All right, so let's add 4x to both sides because I need this to be in standard form. I need this to equal 0. X squared plus 4x plus 1 is going to equal 0. I like to go label my A, B, and C values. A is 1, B is 4, and C is 1. Okay, putting this into the quadratic formula, x is going to equal the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Let's clean this up. -4 plus or minus the square root of 4 squared is 16. There's one minus sign only. 4 times 1 times 1 is -4 all over 2. Okay, continuing with the simplification, 16 minus 4 is 12, divide by 2. So now I have to look at the square root of 12 and see, can that be simplified? So I'm thinking in my head, is there any perfect square factors that the square root of 12 is? Well, square root of 4 times the square root of 3, right? I could rewrite 12 as a product of 4 and 3, 4 being a perfect square. 4 is 2. So when I rewrite this, it's going to equal negative 4 plus or minus 2 square roots of 3 over 2. Using our little heart method, take and draw a heart around all of the outside numbers, the ones that are not underneath a radical sign. Do they have a common factor? They sure do. All of them have a 2 in common. So it's going to be negative 2 plus or minus. I could put a 1 in front of the radical 3. I don't have to. I could put this all over 1. I don't have to. These are my exact answers. And now the approximate I have to get using my calculator. On my calculator, I would do negative 2 plus the square root of 3, see what I get. Negative 2 minus the square root of 3, see what I get. My two answers are negative 0.27 and negative 3.73. All right. For number 4, try that one on your own. So pause the video. I will display the answer. You could check it and make sure if you don't get the right answer that you do ask in class. All right, here are the answers that you should have gotten, your exact and your approximate answers. Please make sure that if you did not get them, that you ask what went wrong, have your teacher go over them in class. Okay, so the last thing we're going to discuss in this algebra review section is to understand and be able to look at a problem and tell which method is best. Because if you choose to use the quadratic formula on every single quadratic you solve, you will run out of time. It's not efficient. It shows that you're not really understanding, how these methods can benefit you to solve the problem as quickly and as efficiently as you can. So the first thing you have to ask yourself, because the one that differs, the way you start it, is this a square root problem? That is the first thing you should ask yourself. So how do you know if it's a square root problem? Because if you can't identify that, you can't really answer this question. And the answer is you would only have a squared variable, so either only an x squared, only a y squared, only a q squared without an x, y, or q, or you have parentheses that are being squared. And if it is a square root problem, you want to get whatever it is that's being squared isolated on one side of the equal sign. The rest of the numbers should be on the other side. If it is not a square root problem, you want to get the equation equal to 0. All right, so if you determine that it is an equation that you're going to use a square root, then what you need to do is get whatever it is that's being squared, either the variable by itself or the set of parentheses, the binomial that's being squared, get that isolated on one side of the equation. If not, if you have an equation that has x squareds and x's, y squareds and y's, then you want to set the equation equal to 0, and after that, you're either going to factor or you're going to do quadratic formula. Again, factoring is more efficient than quadratic formula, so quadratic formula should always be your last resort. What you do have to remember, though, is that not everything can be factored, so sometimes you don't have a choice. Sometimes you are going to have to use the quadratic formula. Okay, so let's take a look, because it's not going to guide you. It's not going to say solve these by factoring, solve these by using square roots, solve these by using quadratic formula. You have to be able to look at an equation and identify whether or not which method you should use, I should say. Okay, so look at this first one. We have 5 times parentheses x minus 6 quantity squared equals 125. To me, it's glaringly obvious that we're going to use square rooting because we have a parenthesis that is being squared. So my first step then is to isolate the whatever it is that's being squared, in our case a binomial. So I divide both sides by 5. I'm left with, on the left, in parentheses, x minus 6 quantity squared is going to equal 125 divided by 5 is 25. So we take the square root of both sides, just like we did in lesson 7, and squaring and square rooting undo each other. I'm left with x minus 6 equals plus or minus 5. Add 6 to both sides. And remember, when I add 6 to both sides, I don't get plus or minus 11. This is both a positive and a negative 5. So I have to add 6 to positive 5 and negative 5. So I have 6 plus 5, 6 minus 5. And if that confuses you, remember, you could write this part as a negative 5, comma, positive 5. So then you know when you add 6, oh, this looks like a little face, doesn't it? When you add 5 to both sides, or when you add 6 to both sides, you're adding it to negative 5 and you're adding it to positive 5. We get our answers of 11 and 1. I'm guessing you would have to do both approximate and exact. This is just exact, so we're done. Okay, looking at number 2. To me, I don't see parentheses that are being squared, and I don't see only a variable squared. I see a variable to the first power here and here. So I know this is not a square rooting problem. This is one that I have to get equal to 0. I like my leading coefficient to be positive, so I'm going to subtract 2x squared, I'm going to subtract 14x, and I'm going to add 3 to both sides. Subtract 2x squared, subtract 14x, and then this plus 3 is a constant. That's going to get tacked on at the end. Gone, gone, gone. 7x squared minus 2x squared is 5x squared minus 2x plus 3 equals 0. All right, one little adjustment I have to make because I just noticed from my notes from last year, this should have been a plus. So that means I would have subtracted 3 here and I would have subtracted 3 here. Okay, so I apologize. Please make that adjustment. If I subtract 3, this right here should now be a minus 3. Okay, because I'm trying to make this one that can be factored. Okay, so if I know it has to be quadratic formula, or I know it has to be one that I'm factoring, let's check if it could be factored first. So factors of negative 15, because 5 times negative 3, that add up to negative 2. Or remember, you could always do guess and check. Factors of 15 are 1 and 15, 3 and 5. Because they are multiplying to be a negative product, one factor has to be negative. Because they're adding up to be a negative sum, the bigger of the two would have to be negative. 1 and 15, negative 15 do not add up to negative 2. 3 and negative 5 do. So I split the middle term. 5x squared. I like to write, if I have one positive and one negative factor, I like to write the negative factor first. So then I have to worry about factoring out a negative. And let's factor by grouping. First two, I could have a 5x that gets factored out, x minus 1, plus 3, and then in parentheses, x minus 1 equals 0. Put my factors together. Okay, so I get 5x plus 3 times x minus 1, that equals 0. 0 product property, let's set and solve for x. Let's set these equal to 0 and solve for x. So I'm going to get x equals negative 3/5, or x is going to equal positive 1. And both of those answers are exact because negative 3/5 is negative 0.6. So even if I write that as a decimal, I'm not approximating anything. That is exactly negative 0.6. So I'm done with that problem. All right, looking at number 3. This is not a square rooting problem because I have an x squared and an x. If I had just an x squared, then I would do square rooting. But because there's an x squared and an x, it's not a square rooting problem. So the first thing I'm going to do, make sure the equation equals 0. It does. Now I'm ready to either factor or quadratic formula. I'm always going to check for factoring first. Are there factors of negative 3 that are going to add up to negative 1? The only factors of negative 3 or 3 are 1 and negative 3 because the product is negative, one has to be positive, one has to be negative. They have to add up to a negative. That would make that a negative 3. That does not add up to negative 1, which means this quadratic cannot be factored. Now, if a quadratic cannot be factored, that does not mean it can't be solved. It can be solved. Every single quadratic can be solved. It's just you're going to have to use the quadratic formula. So this is where we're going to label A, B, and C. A is 3, B is -1, C is -1. Let's plug into the quadratic formula, get your answers. I want exact, I want approximate. Try this and pause the video. We'll see if you get it right. All right, so here are my two answers. X is 1 plus or minus the square root of 13 all over 6. My approximate answers then would be 0.77 and -0.43. I do want to mention that if you are not getting the approximate answers, bring your calculators to class. Your teacher will help you. Every calculator is a little bit different, so they'll show you how to type this in so that you get the correct answer. Because it would be very unfortunate if you get the correct exact answer and then you don't know how to type it into a calculator. So make sure you bring your calculator to class next time, and your teacher will help you. Okay, number 4, I'm going to skip. We could do that one in class together. Number 5, is a very interesting problem because a lot of times students make the mistake thinking that, oh, this is a square rooting problem because I have 25x squared. But it's not, because you have an x on the other side. At this point, a lot of kids want to make up their own math and start square rooting both sides. Remember, you can't square root both sides unless you have what is being squared isolated. This is not a square rooting problem. So you have to follow the other set of rules. So your answer here is no, you can't square root. So what's the first step? Get your equation equal to 0. So how do we do that? Subtract 49x, because I want my x squared term to be the positive number if at all possible. So I get 25x squared minus 49x equals 0. For some of you, you may be thinking, oh, I see this pattern. I see this is a special pattern. This is a difference of 2 squares. It almost is. The reason that it's not is because this x right here. This is not a special pattern problem. This is a factoring by GCF. We have an x that both of these terms have in common, so it's 25x minus 49 is going to equal 0. Now it's 0 product property. X is going to equal 0 from the first factor. X is going to equal positive 49 over 25 from the second factor. Okay, so those are my two answers. All right, last one here. I am going to first check, am I going to use square roots here? I see an x squared and an x, which automatically disqualifies this from being a square rooting problem. So I have to look to the other branch that says, no, this is not a square rooting problem. What do I do first? Set the equation equal to 0. I always want my squared term to be positive if possible, so I'm going to bring over the 15x and the 4 by adding 15x and subtracting 4. So I have 4x squared plus 15x minus 4 is going to equal 0. Always check if it could be factored. 4 times -4 is -16. Factors of -16 that add up to 15. Let's go through the factors first. 1 and 16, 2 and 8, 4 and 4. Because my product is negative, right here, and it's adding up to a positive number, the bigger number of the two factors should be positive. So this would be negative, this is potentially negative, this is potentially negative. I see right away it's -1 and 16. And if you see that, you don't have to write all the factors. That is not necessary. All right, so split the middle term, factor this, solve it, pause the video. I will show the answers and hopefully you got them on your own. All right, here are my two answers. They're -4 and +1/4. Remember that if you are allowed time to work on these on your own, you have to show work. You can't just jump to the answer by copying down what I wrote. We are going to be looking to check that your notes are complete and that you actually attempted it. If you didn't get it right, that's okay. Just make sure you ask your teacher in class the next time you see them and that they go over it. But don't write just the answers that you're supposed to work through and get on your own. All right, that is it for this video on solving quadratics using all the methods. And first we did a quadratic formula. Thank you so much for watching. Have a good one. Bye.